Just begin with this interesting question. Just need to explain you how in discrete time we do the convolution. This is the x of n. So we could see that at x of minus 2 our value is 1, x of minus 1 it's 0, x of 0 it's 2, and for 1 and 2 it's 0, and for 3 it's going to be minus 1, and spot is going to be 0. This is h of n. H of n means what? H of n is an impulse response. Unit impulse response, I would say. Like I would say that if in case my input would have been x of n would have been something like this, okay, 0, 1 and 2, 3 henceforth, but at only 0 value, at of x of 0, if it would have been only 1, then my if this would have been my input, the output would be this one, okay, 2, 1 and 2, 1.5, okay, for x of 0 to be 1. Now what if the I want to calculate the resultant output of all these values, okay, how I'm going to work? I just can split out this one, okay, so would split out and sectionalize into different inputs. Let us look upon one thing over here, that what if only x of minus 2 was there? What if x of minus 2 was only there and 0 and 3 value was also 0, okay? So if only x of minus 2 was present, my output would have been like this. H of n would have shifted to here, okay. As far as LTI system is concerned, it would shift. If my input would shift, my output would also shift, and also scaled by the input. So my input here is 1, so as such no scaling would be impacted, so it's 2, 1.5, okay. This is due to due to only x of minus 2. What if only x of 0 was present? So x of 0 value is 2, so it's going to be 4, 2 and 1. How come? Like we have h of 0, h of 1, h of 2, 2, 1.5, okay. So 2 times 2 is going to be 4, and then 2 times 1 is going to be 2, and 2 times 0.5 is going to be 1. So it's going to be like this. If input was only x of 0, which is 2. What if input is only x of minus 3 and other else units are going to be 0? So my output would be looking like this some way, okay. If I want to find out the resultant output of all the 3 inputs available there, I just need to superimpose. It's very easy. If I want to find the value at, I would say, minus 2, it's going to be the summation of all of them, but we can see here for minus 2 it's 0, for minus 2 here also is 0. The only presence is due to x of minus 2, which is 2. Just 2. For minus 1, we could say it's 0, but only 1 was present, so 1. But for y of 0, the summation would be 4 plus 0.5, and here we could say it's 0, so 4.5. What about y of 1? It's going to be only 2, and we can see it's 0 and both the ends, so it's going to be only 2. Then henceforth it would work this way, and this will be my final output. So one more method which is there to look upon the solution of this is it's very easy. Just need to flip h of n and shift it, okay. What is the flipped version of h of n? It's going to be like this, h of minus n. So it's 0, minus 1, minus 2. It's going to be I would say mirror image of h of n, okay, and just flipped in this way. So for the 0 it's same, but for we can say h of minus 1 and h of minus 2 is the mirror image of the h of n. So it's flipped version of h of n. So I just first of all I need to flip, and then I would shift. So I would have to shift at x of minus 2 in order to calculate the output. So let's see, I just shifted, shifted and flipped. This is the flipped version, h of minus k, and okay, what if my n is minus 2? H of k minus 2 is going to be looking like this somewhere, okay. So I'm going to do one thing, is that only element wise multiplication. Okay. So here if this is minus 2 minus 1 minus, and this is going to be like some way like that. Okay, so element by multiplication I would do. So 2 times 1 is only going to be 2, but here we can see after this element there is no value, so it's 0 here. So if I want to multiply here, so by 0 everything going to be end up being a 0 only. So only multiplication which is possible is with 2 times 1. So we could see the resultant would be 2. What if I shift this one? I shift it. Okay. Okay. Let's see. So by shifting, if I want to do element wise multiplication, so only possibility is with x of minus 2 and this one. So minus 2 it's 1, and here it's also 1. So my y of 2, the value of y of 2, sorry, y of 1 is going to be only 1. We have seen for y of minus 2 it's 2, for y of minus 1 it's 1. What if I shift it again and break it down to somewhere like this, which is h of minus k, and n here is 0. So if I would do element by multiplication, it's going to be what it's going to be, I have to sum up everything over there. Okay, so I could see if I multiply 1 by 0.5 it's going to be 0.5, and 2 by 2 it's going to be 4. So 4 plus 0.5 is going to be my answer for y of 0, which is 4.5. And then I would shift again. After shifting, I could see element by multiplication is only possible for x of 0, and here h of k plus 1, which is for this 0 is going to be 1 times 2. So h of y of 1 is going to be 2. So similarly we can shift it slowly and would find out the values just come out to be like this one only. So the interesting part is like if I want to visualize how this work, I just want to get a feeling, because if we don't get a feeling of something, it doesn't get so easy to digest. Okay, how let's see, I would only look upon how do we get x of 0 is 4.5. Okay, so we have talked before, if my only input would have been at x of minus 2, which is 1, and my other inputs would have been 0, the output would have looked like this. Okay, 2 1 4.5. So now if my only input would have been 2, which is at 0, my output would have been like this. So we could see by summing 4 with 0.5 we get 4.5. Okay, so when we are dealing with this way, okay, so the resultant the contribution of x of minus 2, when I shift this one to get the value of 5 minus 0, the contribution due to 1 would be 0.5. We could see this 0.5 contribution due to x of minus 2 at the y of 0, that's 0.5. Okay, and at y of 0 contribution due to x of 0 is it's 2 times 2, so it's 4 plus 0.5, that is 4.5. So I hope this would have helped you to understand how we find the discrete time convolution. Okay, thank you.